Okay, so first of all, we're dealing with square roots. Grab your calculator and see if you have a square root key on the calculator. You do, right? So all you're doing is putting this number in, hitting that key, and the answer is 7, right? So with a square root, it's something that's like a perfect square. 7 times 7 is 49. If there's a negative on the outside, you're not even worried about it because the answer is negative. Is that clear? So 6 times 6 is 36, right? So this answer, the square root of negative 36 is negative 6. Any questions? Okay. So it's 6 to the second power, it's squared. The answer is 6, but we write it as a negative 6 anytime there's a negative on the outside. Okay? By the way, this isn't negative 6 times 6. If it's outside, it's negative 6. Okay? Now if it were negative outside and negative on the inside, it would turn it positive. But you don't have any of those examples.
Wait, so for the 6 for the second power, it wouldn't be 12?
No.
Why?
What's 12 times 12? 144? That's why it's not that. It's this times itself. So 6 to the second power, 6 times 6 is 36. So that means it's perfectly square. Perfectly square is one side is 6, the other side is 6. It has to be perfectly square. We good? Okay, now take your calculator, take 8 divided by 9, tell me what the answer is. And that's everyone, please. Roman included. 8 divided by 9. Jose, 8 divided by 9. Let's go. Okay, what type of number is that? It's a repeating decimal. Very good. Okay. So if you have a fraction and it's asking you to classify things, you got to deal with the number, right? If it's a square root, you need to solve the square root. If it's a fraction, you want to divide it. Is it a repeating decimal? Is it a rational number? We're going to kind of cover that. Okay, 18. Everything is always over 1, no matter what. It's the same answer, right? But a lot of times when we're doing these fractions, or multiplying fractions, or doing distributive property, or whatever, you have to drop a 1 underneath it, right? So these are 3 different ways to write this, and they're all the same, right? It is a whole number, so there's no decimals involved. 18, we take 18 divided by 1, we get 18. These are the things that it is, that we've described it. This is an integer. We'll talk about that. It's a whole number. It's a rational number. It's a terminating decimal. Do we know what that means? What's the terminator? No, what's the terminator? Everyone here knows it. I'll be back. Terminator, right? From the movie. What does he do?
He fights robots.
Good. And what does he do to those robots?
Kills them.
He terminates them, right? Terminate means stop. Stops them. Okay? The number stops. Are we clear?
Yeah.
Okay. Terminating decimal, natural number. We'll cover that in a second. Okay, in your calculator, take 20 and hit square root. Tell me what number you come up with.
4.4.
Okay, now, follow this. That number goes on forever, right? We don't have a clue what it is. Guess what? Because this number never stops, we can't work with it. This is called an irrational number. And the reasons why it's irrational, we can't put it on a number line. It's constantly changing. Is that clear? When something is an irrational number, it can't be anything else. It can't be a repeating decimal. It can't be an integer. It can't be a whole number. It can't be a real number. It can't be any of that stuff. So a number that's irrational, it's irrational, can't be anything else. Kind of like students, right? If you're an irrational student. Look down the bottom. Okay, powers. Okay? 0 to the second power, 0. Anything by 0, 0. 1 to 1 is always itself. 2 to 2, that's 2 times 4, right? Or, I'm sorry, 2 times 2. 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. These are perfect squares. What a perfect square is, in your mind, think of an actual square, okay? If one side is 10 and the other side is 10, then the total area is 100, okay? Perfect square, the numbers have to be the same, which are the same as powers, right? If somebody gets to the power of 2, it means it's squared, okay? So it's multiplied by itself. Any questions with that?
No.
I have a question. How come 5 isn't up here? Or I'm sorry, how come... Where was I going with that? I forgot.
11? Or what are you trying to say?
No, there was a reason I was going someplace with that. But I just tried to throw in algebra 2, so I'll back up. Okay, so what I want you to do is open your books, go to 34, we're going to go over these words. You need to know these words because these words are going to be in your problems. It's going to say integer, it's going to say whole number, it's going to say terminating decimal, it's going to say repeating decimal. We want to know what this is. So on your do now, isn't the do now super, super easy?
Yeah.
Yes. Put the number in, press the square root key, answer it, okay? But in your do now, I want you to write this stuff down. I'm going to give you real definitions of what these words are. And we're going to go over them a few times to make sure that you guys know what they are, okay? So I want everyone writing this down. Natural numbers, write it down. Jose, natural numbers. All a natural number is, that's a counting number, okay? So write counting number, then right next to it, 1, 2, 3. 1, 2, 3, 4. Those are natural numbers. They're going in their natural sequence. Is that clear?
Wait.
Yes. Write down 1, 2, 3. That'll give you an example. Oh, no. You're writing this stuff down. We're doing this all together.
Alright, what now?
What I just said.
What is the big difference?
Well, at least you're honest. So, moms. Write natural numbers, and then write counting numbers, 1, 2, 3.
What do I do now?
Yes. Then I want you to write whole numbers. Now guess what, Jose? Whole numbers are the same thing as natural numbers, but there's also 0. So, does that mean natural numbers can be 0?
No.
No. Maybe make yourself a note of that. A natural number is not going to be 0. A whole number is going to be 0. And let me explain why it's 0. Think of it on a number line. It's any whole number that's not a fraction that fits on a number line. Is that clear? So we know what natural numbers are, right? They're counting numbers. Whole numbers are the same thing. They're counting numbers, but also include 0. Are we good so far? Yeah. Okay, integers. You're going to hear that word through Algebra 4. Okay? Let me tell you what an integer is. An integer, it's its positive number and its negative number. Okay? So positive 2, positive 3. Okay, write that down. It's number and it's negative. That's what an integer is. And an integer can be 0. Guess why it can be 0? It's neither positive or negative. Okay? That's the only number that happens.
Does it have to be -1, -2?
Yeah, write down an example. An integer would be, bless you, 2 and -2. So if I say, Jose, what is the integer of 2? -2. And if I ask you, what is the integer of -3? If I ask you what the integer of -3 is, very good. You guys got it. And 0. Okay? 0 can be an integer. Because on a number line, positive or negative is right in the middle. It can be both. Okay?
Opposite number.
Yes. Okay, rational numbers. All a rational number is, it can fit on a number line. Okay? The difference between irrational and rational, okay? The square root of 20 is an irrational number. This goes on forever and ever. A rational number stops at some point. It can be a repeating decimal. It can go on for a little bit. It can have a pattern, but it has to stop. The reason why it has to stop, you want to think, can I get it on a number line? Well, if we get it on a number line, it has to terminate at some point, right? It has to stop at some point. Okay? Are we clear on that one? What a rational number is? It stops, yeah. And remember, the key thing is, can you put it on a number line? Okay? Can you put 4.3251 on a number line? Yeah, you can.
It's right.
It's easier to put as a fraction. So it could be a number and a decimal, right? Think of, and I would write, I can put it on a number line. Okay? And you'll remember that. Jose, make the pencil sing, please. Okay, repeating decimal, we covered that, right? How you find a repeating decimal in a fraction, put it in a calculator and divide it, okay? That's how you convert a fraction to a decimal, right? Repeating, there's going to be a pattern, okay? By the way, repeating is the number that's repeating. It's not a sequence of numbers. If it's going 675, 675, 675, that's not a repeating decimal. It has to be 77777. And how you know typically in the calculator, it's going to have that little line above the number. Have you guys seen that before? That little line means that number is going on forever. It's not stopping. It's repeating. Okay, we covered irrational numbers, right?
No.
The square root of 20. That number goes on forever. We can't put it on a number line. It never stops. Okay, real numbers. What do we think a real number is? I said it a couple of times. A real number could go on a number line. Write that down. Okay, I just gave you real scenarios of what those words are, okay? So when you get to your worksheet,
Wait, real numbers.
real numbers can go on a number line. So is 1.5 a real number? Yeah, it's 1.5, right? Is 0.5 a real number? Yeah, it's a half.
Really?
Yeah, we can graph a half on a number line, sure. But can the square root of 20? No, that number never stops. It goes on forever and ever and ever. There's no place for us to graph it. Okay, so flip over your notes, look at your worksheet for a minute. Very similar to the do now, right? I want you to look at number 6. You remember when we talked about fractions and how you do the power of fractions? How do we solve those? No. Power of fractions. How do we solve this right here? If we're 2/3 to the second, how do we solve that?
2/3 multiply 30.
Okay, then I multiply the top by the top and the bottom by the bottom.
Yeah.
So this becomes 4/9. Are we done?
Yeah.
Yes.
Yeah.
Yeah, we can't reduce that. 4/9. Okay, look at number 6. When it comes to solving these, it's the same. It's 2 problems in one, okay? So it's saying negative on the outside, so your answer is negative, okay? You have 2 numbers in a fraction. It means it wants the square root of 4, and it wants the square root of 25. Well, how do you know the answer to that? 25 and 4, right? There's your square roots. So how would we write that?
2 over 5.
2 over 5. But we go like this, right? Can we take that down further?
No.
Put the square root of 2 in the calculator and tell me what it is.
I don't have that thing.
Yes, you do.
Yeah, but it has the X right there.
You have it. Okay, what's the square root of 5?
25.
Put the symbol in and put it to 5. Okay, it's a decimal, right? So this right here is simplified. So this is how we solve this problem, okay? It's going to be negative on the outside, so our final answer is negative 2 over 5. Okay? Because the square root of 4 is 2, and the square root of 25 is 5. This is my answer when it's all said and done. Don't allow the fraction inside the square root.
Is it the answer for number 6?
Sure. Yeah, don't be the 1, right?
How do we do 9 through 14?
Okay, you have lines, right? Those lines are asking you to describe the words. Now, we just talked about those, right? So look at that fraction, 2 divided by 3. What's the answer? We'll take 2 divided by 3 in your calculator and tell me what happens. Yeah, so that's something we could classify it as, right? Is it also a real number? Sure, it can fit on the number line, right? Is it an integer? That and its negative number, they could be integers, sure. However, I wouldn't call 2/3 an integer because it's not negative, but look at 11. That one's negative 10, right? So what's plus 10 versus negative 10? That's the integer, right? So anytime you have a negative number, you want to call it an integer. So what you're doing on 9 through 14 is you're classifying these numbers. Now, looking at these, aren't pretty much all these terminating decimals except for number 10? Yeah. Just like 18 over 1 is 18.0, it terminates at 0, okay? So the reason why you're given multiple lines, those words that we went through, you want to go and describe these. Look at 7 and 8. Let me give you a little hint. It's asking for the square root of 12, and it's asking for the square root of 27, and it's asking you to round it to the nearest 10. Okay? So do the square root of 12, get your answer, round it to the nearest 10. How far is 10 on your number line? If I'm dealing with a number like this, which one's the 10th spot?
The one.
Yes, what's this one right here? What's this one called? What's that? No. This is tenths, this is hundredths, this is thousands.
Oh.
This is ones, that's tens, that's 100s. You add that TH at the end of it, but it's always tens, hundredths, thousands. Okay? So if it asks you to round to the nearest 10, that means this 5 is going to change this number to what? 3.2, right? If it's 5 and or greater, we increase the next number. What happens if it's 4? What if it's 3.14? What do we do? Just get rid of the 4. 3.1. Okay? Any questions?
How did you do number the A on the top?
Put 49 in the calculator. Press that key. It's 7. 7 times 7 is 49.
Okay.
And that's what a perfect square is. So, are there any perfect squares on there? What about 12? Isn't 12 a perfect square? So you could say that, perfect square. Is it a terminating decimal? Yeah, it's a terminating decimal. Is it a real number? Yeah, so that's what those lines are for. You're going and describing those, okay? Okay, any questions? Okay, make it happen. Do you want to have
Can you go over that?
the rounding?
Yeah.
Okay, it's asking us to round to the tenths, okay? So that's this first spot here, okay? So if this next number is 5 or greater, we increase this next number by 1, okay? If it's 4 or below, we just get rid of it,
Right.
okay? So it's 5, 6, 7, 8, or 9, we're increasing the next number. Make sense? Okay, all right. Okay, so you want to label all that stuff, you want to solve those. How do we do this again? Square root with fraction in it? Two separate problems. Two separate problems. Good. Okay, make miracles happen.
No.
You want to have your notes, your vocab done. The stuff that I said in regards to your do now, you want to know what those words are. If you forgot, go on to page 33 and write them down. Okay?